So glad that you are here this morning for Community of Learners lecture, Q&A. You know, Psalm 19 says that the heavens declare the glory of God. And we have here someone who has seen things in the heavens, been places that I would say none of the rest of us have been. And so it's an extremely, it's a blessing to have you here, and we're going to hear more about our special guest speaker. I'd like to introduce our Associate Vice President for Academic Affairs, and he's also Dean of our new School of Engineering here at Spring Arbor University, Dr. Ron DeLapp. Would you come in?
Well, it's been a blessing to be here at Spring Arbor. This is a special place. I've been at several faith-based universities, and this, I can say, this is a very special one. It's a very special place. It's a real commitment to Christ here that it's not artificial. That is thrilling to me. I love it. So I'm older than most of all of you. I could be a grandpa, probably, for many of you in the room. One thing you'll learn when you get old like me is, and if you're really smart, you'll learn it sooner. One of the biggest blessings of life is the friendships that you have, and especially friendships with your brothers and sisters in Christ. And Dr. Lichtenberg is one of those friendships of mine. He came to work for me when I was at Eternal University, and he's still there teaching. He has a PhD from MIT, or an EdP, I guess. He's got a doctorate from MIT, I believe. I got that right? Yeah. Equivalent. Been to space twice, military career, flew for Southwest for a long time. He's got all these incredible accomplishments in his life, but you would never know that if you just walked up and talked to him, because he doesn't wear it on his sleeve. He doesn't think he's anything special. He's just one of our Christian brothers in Christ. I'm thrilled that he was able to come up here today and talk to us a little bit about his experiences in space and his perspective on faith and what space does to you after you go to space. And also just to have some fun, see a home movie and some other things. So I think I'll leave it at that and hand it over to Byron and let him take it away. Thank you, Byron.
Well, great. Thank you very much. Appreciate it. That's a nice introduction, Ron. So I'm very blessed to be here. I'm going to talk this morning a little bit about my second space shuttle mission. Just as a little more background, I always wanted to be an astronaut since I was a kid. And one day I woke up from reading my science fiction books and looked up, and there goes John Glenn. And I said, oh, wow, I guess that can really happen. So I looked at the career path of the early astronauts, and they were all military test pilots. So I said, well, gee, I guess I've got to go be a military test pilot. And I looked back at what that was. Well, you had to be a military pilot, you had to have an undergraduate degree in STEM, then you needed a master's degree, and then you go to test pilot school and maybe get selected. So I backed all that up and said, well, fortunately I like science and math, and engineering is kind of cool because I like to build things. So went to Brown and did my undergraduate degree in aerospace engineering. Went in the Air Force because that's what I had to do. And fortunately, I had 20/20 vision, got into pilot training, did a good job there. Had a fighter assignment, got checked out in the F-4 Phantom, and then was sent to Vietnam, did a tour over there, spent 9 months, 138 combat missions in Vietnam during 1972. And at the end of it, said, well, the next thing would be to do another operational tour and then get a master's degree and then try to get into test pilot school. But God has a way of changing our paths. And my wife at the time was pregnant, and the Air Force said, hey, we're going to send you back to the United States for a year before we send you remote for a year. And I got my next assignment to go to Iceland, which happened to be remote. And I said, well, wait a minute, where's this 1 year back in the U.S.? I said, oh, well, no, we need you in Iceland. And I said, well, what are my options? I said, well, you can get out. So that was one of my turning paths there. And so I decided to leave active duty, go back to graduate school, and I wanted to do a biomedical engineering degree. I was really enamored by Steve Austin, the $6 million man, and wanted to work on some prosthetics. And turned out MIT had a group working on the Boston arm. So applied to MIT, was accepted at graduate school in the mechanical engineering department, did my master's there. Went down to NASA and told them I was trying to build Steve Austin, and they laughed and said, "No, we're not doing that." So they said, "But we are doing work in space motion sickness and inner ear modeling the vestibular system, your inner ear organs of balance." And there's by the way, a really good lab group at MIT in the Aero Astro department. So I switched, went over there, and had some funding, and told them what I wanted to do. And about a year later, NASA says, "Hey, we want to fly some experiments on the space shuttle in the space lab." And guess what? Our focus is on space motion sickness. So we were in the right spot at the right time. Again, you know, God is moving us where we need to be. And so we proposed experiments. They were accepted. And then NASA came back and said, "We want to fly some scientists. They're not going to be career astronauts. They're going to stay in their scientific institutions. They'll be associated with the experiments. And they're going to be called payload specialists." So my boss nominated me. After a couple of interviews, they selected me and Mike Lampton from Berkeley to be the two payload specialist trainees for this mission called Space Lab 1. Concurrently, they had 3 European Space Agency astronauts, and the deal was 1 American and 1 European would fly on this mission to do experiments in the space shuttle and the space lab. So after 4 years of training, I was selected to fly, and Mike was my backup. And a year later, we flew STS number 9, which was on Columbia with John Young as the commander. November of 1983, up for 10 days. Had a great time, did 72 different experiments, and came back, and a couple months later, they said, "Well, we're going to fly some of these experiments again. Would you be Mike's backup?" I said, "Sure." And then they called a week later and said, "Well, we need another payload specialist. Would you want to go fly with him?" I go, twist my arm. Sure. So that was probably about the easiest space flight assignment anybody ever got. Went off, started training for that mission, and then the Challenger blew up. And we got pushed back for about 6 years. So I started a company called Payload Systems, and we did some work with the Russians, ended up flying some commercial experiments with the Russians while the space shuttle was grounded. We also did missions on NASA's Comet, I should say that. And I noticed that so many people were really excited about flying in zero-G weightlessness, and that they would propose experiments just to be able to get on there and kind of do it. And I thought, there's going to be a business here someday. And sure enough, after my second shuttle mission, I started another company called Zero Gravity Corporation, and we're today flying a Boeing 727. We're doing that for 16 years now, flown about 15,000 people. So there really is a business there for that. So getting back to space, finally got ready to go. Flew in 1992, which is what this movie is. Home movies from space. I want to apologize for the quality because it was 1992. And we didn't even have digital cameras yet. So a lot of this was very grainy, transferred it from 16 millimeter film to discs to thumb drives and things. So it's lost a little in the translation, but I narrate it. So it's not just going to sit here and listen to 20 minutes of somebody talking. I like to show it because it helps me relive the experiences that I had. So STS-9, or STS-45, excuse me, commanded by Charlie Bolden. He was a Marine Corps fighter pilot, ended up being the 12th NASA administrator for 8 years, and an extremely good friend of mine. He was our commander. You'll meet the crew here in a minute, but we had Kathy Sullivan on. She was the first American woman to go do a spacewalk, and she worked on the Hubble and did a lot of things. She was the payload commander. Had a crew of 7. We worked 2 12-hour shifts, so we kind of hot trunk. If anybody's in the Navy, they know that term. So we would go out, do our 12-hour shift, and then take some time off, have dinner, maybe sit up on the flight deck for a while, and then go to bed and repeat it. So that mission was March and April of 1992, 9 days in space this time. So I've got a total of 310 orbits, about 4.5 million miles around the Earth. So the movie is a compilation of different things. It goes by pretty quickly as I narrate it, so if you have questions, please try to hold on to them until after the movie. I will have a Q&A session from that, okay? Once the movie's over, We can talk about that in a few minutes, but I have just a few slides about not looking back, but looking forward. We're going to talk about the Project Artemis, which is NASA's goal to go back to the moon on the way to Mars. Okay, so a few minutes kind of give you a little primer about what's coming in the future, and then we'll talk a little bit about the Earth. So that's the way it's going to go. We'll try to get the lights down, and I'm going to see if I can figure out how to do this here. And find the play button. I didn't know I was working on the lights. The movie's kind of dark because a lot of the stuff happens at night. So she's working on it. Well, we may try it. I'll just keep working on the lights now. Oh, there we go. Yay. Okay. All right. So we have our countdown timer, 4, 3, 2, 1, and we're going to show the sponsor. Here's the NASA worm, and this is our mission patch. This is me over here. Dirk Freemount was the guy that flew with me from the European Space Agency. So here's Dirk, kind of looked like Albert Einstein, Kathy Sullivan, young days, our pilot Brian Duffy, Charlie Bolden, the commander, Mike Fold, that's me, believe it or not. This is David Leisman, he was our flight engineer. So after the Challenger accident, we started wearing partial pressure suits, so we get all suited up and put our parachutes on and everything, and get ready to head out to the launch pad. I got suited up first, so they let me do the original couch potato, so they gave me the TV remote here, so I'm working on the TV. So we walk out early in the morning, drive out to the launch pad, go up about 200 feet in the elevator, climb into the space shuttle, everybody runs 5 miles away, and now it's time to go. So they start up the 3 space shuttle main engines, you're probably familiar with that. Once they're up to speed, they fire off the 2 solid rocket motors, and boom, you're going to be going someplace in a hurry, okay? Boom. There we go, this is real time, tower is clear. As soon as we get clear of the tower, we do a big roll maneuver to orient the shuttle so that we're going up right along the coastline of the eastern U.S. There you see the roll. You're going to see that from a different perspective here in a minute, but realize that we have about 7.5 million pounds of thrust on a 4.5 million pound vehicle, so we start going uphill at about 1.5 times the force of gravity to start. Over the first 2 minutes, riding on the solids, it's like driving a pickup truck down the railroad tracks at 60 miles an hour. There's a lot of shaking going on, a lot of vibration. It's hard to focus on the writing in the screens in front of you. After 2 minutes, we're up about 30 miles. We're doing Mach 4, 3,000 miles an hour. And the space shuttle, the solid rocket motors are out of fuel, so they get jettisoned. And immediately, the G level drops back to 1/2, from 3 to 1/2. So it kind of feels like you've been thrown forward in your seat. Very smooth now, the liquid fuels space shuttle main engines, very, very smooth. So imagine you're the pilot, you're lying on your back, you're looking out the right window, and here's what you see, the coastline of Florida, this is the Atlantic Ocean. We're getting ready to go, there we go, we're tower clear. Watch the roll maneuver, I want you to look in the upper left-hand corner. Remember, this thing is 4.5 million pounds. It really swings around very rapidly. So up is in this upper right-hand corner. This is the coastline of Florida. And the first thing we do is go straight up to try to get out of the atmosphere as soon as we can, and to stay as close to the runway at Kennedy Space Center as possible in case we have to do what's called a launch site abort, okay, return to launch site. So as we get through the second cloud layer, you can see the vibration with the shuttle solid rocket motors. Starting to get purple, violet up here, and we're still seeing the coastline of Florida right there. We're going to go up, like I said, for those 2 minutes. At the end of the 2 minutes, once the solids are out of fuel, we'll jettison those, and what you'll see is you'll see the horizon pitch down from being here to kind of like this. So you'll see an actual pitch over, and you probably won't notice it, but the ride gets very, very smooth. So going up the coastline of the United States, I actually cut out, there's the pitch over right there. I cut out a couple of minutes over Georgia and South Carolina because it was clouds, couldn't really see anything. What we're going to do is we're going to get up to about 300 to 400,000 feet, and then we're going to pitch over and go right along the surface of the Earth to get enough speed to go into orbit. And that speed is about 17,500 miles an hour. The whole ride to space is 8 minutes. That's it, 0 to 17.5 in 8 minutes. And the last 2 minutes of that ride, we're at 3 Gs of acceleration. Now 3 Gs doesn't sound much. You pull that on a roller coaster. As a fighter pilot, I would routinely pull 5, 6, 7 Gs. But this is different. This is 3 Gs for 2 minutes straight. And if you do the math, that's approximately 6 Mach numbers of speed increase every minute. So the first 6 minutes we get to Mach 13. The last 2 minutes we get to Mach 25, which is the orbital velocity. So here we come. We're looking west now. You can see the blackness of space. If you look down here, coming up in the lower right-hand corner, pretty soon you'll see the Outer Banks region. We'll see a couple of the rivers, the Albemarle and Pamlico Sounds there in North Carolina. Beautiful day over central U.S. here, looking to the west. So you can see them down here. Here's another one of the river regions. And then coming up over the Outer Banks, you'll see a little cloud layer, and then we'll be looking at the Newport News, Virginia Beach area. Things are accelerating pretty rapidly now. We're at that last 2 minute phase. So here's the Outer Banks. Virginia Beach is here. Chesapeake Bay, there's the bridge tunnel. See that? All of the Delmarva Peninsula, Baltimore's right here. Washington, D.C., Baltimore. We've got the Delaware Bay coming up, and this is where we go main engine cutoff. This is Dover Air Force Base. So right here, we're now at our orbital velocity, but we're still down about 500,000 feet. And things are going by pretty rapidly. There's Atlantic City. Right there. Coming up to the New York Harbor region, you can see Manhattan. Statue of Liberty's right there. We've got Long Island Sound, a few clouds over New Haven, Connecticut. You can see Block Island coming down here. Things are going pretty fast now. We're coming by Providence, Narragansett Bay, where I did my undergraduate work. We've got Block Island, we've got Narragansett, and we've got Martha's Vineyard. Here's all the Cape Cod. There's Cambridge, MIT's right there. And Provincetown. Good. So we get off the external tank, and we're not quite at orbital velocity yet, so the tank goes in and lands in the Indian Ocean. Once we get on orbit, we open the cargo bay doors because the radiators to reject heat are inside of these doors. And we have instruments that want to look out into the darkness of space. So we have these big spheres. They're actually like grounding rods to the environment up there. We've got a computer, all these different instruments. And generally the Earth is up here. It's just gently curved. Remember, we're only up a couple hundred miles. So we're like the fuzz on a tennis ball. That's how high we are. So the Earth is really most of your field of view. So it's starting to get dark now. I was crewed up with Mike Foale, who was on his first shuttle mission, and Davey Leisman. So we went to bed. It was about 10 in the morning. We were on the night shift, the red shift. So Kathy and Derek got the instruments up and going. Charlie and Dave and Brian were changing the space shuttle from a rocket ship to a space station, mini space station for the week. So they're going through all their different checklists, and we are in orbit. So coming down here in the lower left, you can see some of the Amazon River. Pretty impressive. So here are Dirk and Kathy. Most of the experiments were done at night and going into sunrise and then going into sunset. Okay, and I'll explain that in just a moment. First thing we had was a very sensitive telescope. This is called a photon counter, and its ability to have filters in there to look at the different wavelengths and different colors of light. And we're going to use this to study both the natural auroras and an artificial aurora borealis, the northern lights. We actually are going to create some of those on this mission here in a minute. But first I want to show you what a natural aurora looks like. It's a little hard to see because it's real grainy, but you can see it down here. Okay, so this is the Earth, and this is the aurora coming through here. This is that telescope in the field of view. So, like I said, early days, pretty bad video, but you can get an idea of kind of the sheets of light. It's really, really impressive. So here's a meteor coming down there in the lower portion of the Earth. This is the surface of the Earth, and this is called an air globe. We'll talk about that in a minute. So what we have is we have an electron beam accelerator here, and we're going to send out a 1-second beam of electrons, and we're going to shoot it up into space, and you can kind of see the beam light up as it goes out. The object here is to look at the input-output relationship between the energy of the beam, so we know the voltage of the current, and then the whatever it excites in the lower atmosphere. So this is looking at the screen, so we're going to do this several times. So the beam comes out, okay? And we look into our screen. If you look right about here, you'll see a little blip of light. That is the artificial aurora that we actually created. And we can look at the different colors of light that are being excited in the lower atmosphere. Some of the filters like nitrogen, 3914, and we can figure out the energy of the beam and how it gets transferred into the upper atmosphere. By doing that, we can then start to understand how the sun's energy gets transferred into the atmosphere. Oh, we did some other experiments. We had some film cameras with an image intensifier taking pictures of the atmosphere at night, and we could put different filters in there to be able to, again, understand what particular atoms and molecules are being excited in the lower atmosphere. So the northern lights are kind of like Mother Nature's fluorescent light system. You can think of it that way. Okay? So we do a lot of things. This is kind of a nice picture. These are thunderstorms. This is coming over South America. Here is the horizon. Okay? And you'll see these thunderstorms go because we're actually coming out of the plane of the movie here. Okay, so we're moving back this way. So these guys will go off and disappear behind the horizon. City of Buenos Aires, Argentina, and so we're going over the Atlantic Ocean, headed over towards Africa. This dark line, bright line here is called the air glow layer. The air actually glows at night. So that's up about 80 kilometers, just to give you an idea. And again, these thunderstorms were so bright you could actually read the writing on the instruments inside the cargo bay of the shuttle. Here's the Southern Cross. I've never been in the Southern Hemisphere on the ground, so I thought I'd take a picture of the Southern Cross and do a little zoom in here with our Zoom TV camera and see what it's like to go warp speed into the Southern Cross there. So had a little bit of fun with that one. So we're going to kind of move inside a little bit and talk about some of the other experiments. Mike Cole here is working on one of the very early laptop computers called the grid computer. And we have a spectrometer which looks at the different colors of light that are absorbed by the atmosphere from the sun. Okay, so here you can see some different colors. You get a thunderstorm here or two. There's some more over here. And as the sun rises and sets, we can take like onion skin pictures of the different layers of the atmosphere as the sun comes up and goes down, and understand what particular atoms and molecules are there by looking at what colors of light are being absorbed. Okay? So pretty cool. And once we had sunrise and the sun was up above the atmosphere, our job was to take pretty pictures of the Earth. So that was pretty cool. This is the middeck. This is where we live. These are the bunks. There are 4 of these bunks. I guess they're like coffins. About 2 feet by 2 feet by about 6.5 feet, so I just barely fit in there. So we're on the red shift. We're working all night, sleeping all day. So I got my red shirt on. I'm going to ham it up a little bit. It'll be on. Time to wake up. Had our shaving kits here. This area is everything. It's our kitchen. It's our gymnasium. It's our bedroom. It's our bathroom. It's our closet. So here's Kathy. We all took turns cooking, but she happened to be doing it this day. Most of the food on the shuttle is dehydrated. I'll tell you why in a moment. So we have these little packets of dehydrated food. We put them in this little tray, and then you can dial up the number of ounces of water and press either the hot or cold button, depending on whether it's supposed to be hot or cold. If you want to heat it up, there's a little convected oven right here. We put them in just to warm them up. And everything has been cooked. It's irradiated, dehydrated, you name it. Not really great food, but we didn't go there for a gastronomical meeting. So we have, all of our drinks are also powdered. You see these foil packets of tea, coffee, lemonade, whatever you want, different juices, including Gatorade. And one of our favorite foods was shrimp cocktail. So here's a shrimp doing a backflip in the baby's. So get that little thing. Yeah, a lot of the food kind of gets thrown away, kind of goes away, floats away. The only place where adults can play with their food is in space because the kids love it, right? So here's dessert, M&Ms, Mr. and Ms. Pac-Man, Charlie and Kathy, going at getting those Emmys. One of them's going to get away, so I want you to watch this reverse slam dunk Charlie does. Here he goes, boom, gotcha. You're not going to get away from me at all. Did some fun things. David was a ham radio operator, so we brought a ham radio on board, and we talked to all 7 different continents during our mission, which was really pretty cool. We also used that to talk to our families on a private channel so we could have a private conversation, which was pretty cool. Very nice. So you can see the shuttle. It's not real crowded, but you can use the volume instead of just the floor. Charlie's doing some exercise on the treadmill. If you can read lips, I think he says, "I hate this" in a minute. It's a shuttle shuffle. You don't get very much things. Here he goes. He's going to go up there and I think he says this. Close enough for my book. So the treadmill, the shuttle shuffle here, comes off, and then we have these containers of chemical called lithium hydroxide, which we use to scrub out the carbon dioxide that we humans exhale. And about every 12 hours, we have to replace those cartridges. So we have to take the treadmill off of the floor to get to it. Well, if you look in the upper right, there's the foot, this metal foot. So the treadmill weighs about 80 pounds on Earth. Of course, it's weightless in space, but it still has mass. And Michael is up there trying to spin it. And if you look at David's right or left ear, he almost gets bonked in the head here. I was looking at it and said, oh, this isn't good. So here it comes on. Here's the one right there. Ooh, ooh, ooh. That was close. So we saved him that day. Didn't want to have to do surgery on head wounds. But there you can see Michael spinning it. So he was happy. We have a lot of chores to do. Like I said, we do the lithium hydroxide and things. We also have to take out the garbage. And David had little kids at the time, so he showed you how we take out the garbage. We have a place below decks. But David, watch out, David, watch your hand, watch it. Don't let the trash monster get you, David. No! Safe, we're safe. Let's have a heart attack on that one. So we had some fun. It was a really good time. Played a little golf. Place to golf in space. So no, we didn't take golf. This is an inspection mirror, and this is a sock with Velcro on it. And we're going to do a drive. Ryan's going to do a drive here. 1,001, 1,002, 1,003. 3 seconds, 5 miles a second. That drive was 15 miles. So pretty good. So Ryan's going to set it up. He's going to kind of plumb bob if you're a golfer. There's the ball, and our golf hole was a roll of duct tape with a government issued pencil on it. David says, no. You're standing on the floor, but you got to go with respect to the earth if you're going to do this plumb bob deal. So he said, the earth is up here, so I got to get my feet up here, and the putt's going to break the other way. So you just didn't read that at all. It's going to go up that way. So they give me the putter, and I've got my shades on. The future's so bright. I got to wear shades, and they asked me to make that putt. So there we go. We got a birdie on that par 3 hole. So had a little bit of fun. And you see the number 45, which was our mission number. Here, sort of see it. There it is. So a little bit of fun. One of the Capcoms was a West Point graduate, and so Charlie and Brian. So Charlie and Dave were Naval Academy. Brian was Air Force Academy. So they had a little bit of rivalry with West Point. Charlie, the ultimate commander, puts his Walkman on. Yeah, Dave had actual Walkman. Looking out the window, watching the earth go by. Hey, you swabbies, let's start getting this thing cleaned up. So here we go. There's Kathy, who's a Naval Reserve officer. She's working on cleaning the mid-deck area along with Deer. You can see him over here. And Brian, there's Brian. So these are some of our lockers. So this was the closet portion of the space shuttle. The rest of us were asleep in here while they were cleaning it up. There's a picture of Deer. And once we woke up, then our job was to clean the flight deck area. So we didn't get out of doing some of the cleaning. You probably saw that little bit of shrimp cocktail juice. Well, a lot of food and crumbs and dust and everything collects on it. So we're trying to police it up a little bit before we get ready to come home. So after 10 days, we're about out of electricity. So we close the cargo bay doors and make sure everything's latched up, put our orange pressure suits on, and get ready to come home. So coming home was interesting because we start over Australia. We turn the shuttle around upside down going backwards, and we only slow down 1% of our velocity. So instead, from 17,500 miles an hour, we only slow down 175 miles an hour, but that's enough to break orbital speed, and the shuttle starts coming into the atmosphere. And it does that. It runs into the atmosphere at about Mach 20, and heats up the atmosphere, causes these plasma discharges, and then also the heated glow, 3,000 degrees Fahrenheit, right outside the window. And from our knowledge of the Columbia accident, it could cut through aluminum like butter. So we were fine, but you can see that plasma discharges, all this almost like lightning. as we come in, we come over our intended runway, which is the Kennedy Space Center. We're about 50,000 feet. We've slowed down to just under the speed of sound. Charlie kicks off the autopilot and flies a big descending swooping turn, decreasing energy to come in and land on the runway at Kennedy Space Center. If you have any glider pilots, this is a glider, and the rudder back here is actually a split rudder because it acts as a speed brake. So since you don't have any thrust, what you do is you put the rudder partway out, and then you can modulate it. So you can either increase the drag, put it out more, or you can put it in to decrease the drag and essentially give you a little more energy. So nice job on the shuttle landing. We came in again on runway 33 there at the Kennedy Space Center. We come down to about 1,900 feet, coming down at 19 degrees, slow the descent down at 500 feet. We put out the landing gear and then slow it down even more to about 1.25 degrees and touch down on the runway. You can see Charlie did a really nice job. These were the days before they had a drag chute shuttle. So the shuttle weighs about 200-something thousand pounds and has just 4 main tires. Airliners that weigh that much have 8. So we generally had some problems with hot brakes and blown tires. That seemed to happen about every mission. Coming in pretty fast, and the runway is only about 3 miles long. So that's how I spent my spring break, 1992. Okay. So let me stop that. Oops, so I'll play again. And let me do this. Let's take a minute and have some questions about the movie, okay, before I go to the next portion of it. So I'm sure there's got to be some questions.
All right, who's first?
Get a sip of water.
Thank you so much for that very personal view. That was very interesting. I was just wondering, I beg your pardon for this, but did you say that you were on the Columbia that later had the accident in the early 2000s?
My first mission was on Columbia, yes, back in 1983.
And then that later?
That Columbia was the orbiter that came apart over Texas in 2001, yeah, kind of sad. Yeah. There you go. Thank you, National.
Hi. You detailed like just the everyday things that you had to do, like cleaning, but then you're also doing experiments. How did it feel to have that mundanity while you're just seeing the wonders of space?
That's a very good question, because yes, we have to live and work in space, right? So we had to cook. Hate to say it, but we had to clean the toilet. That wasn't a lot of fun, believe me. I can tell you stories about that, but the space shuttle waste management system has always been a sticky point. But it's just, it's just things you have to do, to live and work in space. So yeah, we had housekeeping chores to do. We would do paperwork. That's not a lot of fun, but we had to document the things we were doing with the experiments, and if there were changes to the procedures that would come up and things. So it was a little bit surreal. I felt very blessed because my first mission, we had the Space Lab module, which is like a big giant tin can bolted into the cargo bay, and we had a tunnel from the mid-deck that we go through to get into the Space Lab module. And there weren't very many windows in there, so we really couldn't look out much, and we were really busy about 14 hours a day doing experiments. The second mission, all of our experiments were controlled from the aft flight deck, right behind where the pilots sit. And all the windows were up there. And like I said, during the daylight side, our job was really to kind of look out and take pretty pictures of things we saw. I mean, it's a little more involved than that, but basically that's it. If there are interesting geologic features or whatever, then we would take pictures. So all of our work was done during the night side pass. So remember, shuttle goes around about every 90 minutes. Okay, so that's 16 orbits a day. So you get 16 sunrises and sunsets every day. And that's why we were doing all these experiments with looking at the upper atmosphere and trying to understand what the composition of it is. But, yeah, yes, sir.
What protection do you have from space junk or from rocks in space, like the things that would become meteors or meteorites?
Good question. So we do have a lot of people looking out for us. Okay, the NORAD, the folks in Colorado, track about 10,000 different objects from the size of a marble on up. And if we come close to something, they will let us know generally a day or two ahead of time, and then we'll make an evasive maneuver to avoid it. The space station does that every day. They build a 5-mile bubble around the space station and actually move it if something's going to be coming close. If something's really small, you just hope that you've got enough aluminum skin there to help protect you. We have had instances where the shuttle has run into small things. This particular thing had to be a piece of frozen liquid waste from one of the Russian space vehicles. It actually pitted the front windshield of the shuttle at one point. Things like, space rocks, debris, things, there just, kind of isn't that much around. It just, very little of that gets into orbit. It may come through like the meteor that you saw, but we go on the big sky theory. I hope you're not there where it's there at the same time. Yes, ma'am.
I have two separate questions. One is, what was the finding from all your experiments that you found most exciting? And the second, and then I have another question.
Okay, we'll go to that one too, and I'll get it over.
The second question is, if, then how did your faith change as a result of this experience?
Okay, good question. So, yes, so I think the most interesting finding really was with this artificial aurora, because that's the first time we'd ever done this, to be able to create our own artificial aurora, and to see the way it actually tracks, and you can actually see the movement of it in the lower atmosphere, and then they were able to really get some good, use the word transfer functions. In other words, how the energy from that beam gets transferred into the upper atmosphere. I won't go into more detail than that, but I think that was really pretty fascinating. So that was good. Yeah, in terms of my faith, I would look out and you look at the Earth and it's just so beautiful. I mean, all the colors. The thing that surprised me most about this is just, it's not just blue and white and gray or what, I mean, it's pinks and purples and yellows and just vibrant Earth. And then you look the other way and it's black and white. You go, wow. Every human being, all of civilization as I know it, is on that planet below me except for 7 people. And so that's pretty humbling. And you really look at it and go, wow, this creator of ours is really something. It's really amazing. So just blessed to be able to see that. Let me take that instant then to talk a little bit about, before we go into this, I helped start a group called the Association of Space Explorers back in 1985, a group of astronauts, cosmonauts. Anybody that's been in Earth orbit is allowed to join, able to join. So we probably have about 400, about the 600 people that have been in orbit in the organization, and we have a yearly congress. And one of the things that surprised me in the early days was sitting there the first time and talking with some of the Russian cosmonauts, and they had guest flyers from a bunch of different countries. And so we had 10 Americans, 10 Russians, and 5 internationals. And it didn't matter if you were a Saudi prince, a Mexican engineer, a Vietnamese fighter pilot who I probably flew against in Vietnam, in there brushing your teeth next to each other in the morning. Talk about a very surreal experience, right? 15 years later, you're there and you're brushing your teeth next to the guy that you're fighting. But we shared this common bond and we talked about it, and we realized it didn't matter your educational background, whether you were a US congressman or senator, or like I said, a Saudi prince or a Russian test pilot. We all had a change in us, came over us, in terms of our perceptions of being not just a Texan or a Michigan or an American, but really becoming a global citizen. And I think that's really kind of one of the big messages that we like to give when we do these talks. Is that perspective of space and seeing the whole Earth, everything we know, in 90 minutes, and realizing that unlike the globe that you have on your desk, which has all the countries in neat little different colors and dotted lines and things, that's not the way it is. It's really a world without borders. the groups like Doctors Without Borders, those kinds of things are very, very cathartic and very healing. Yeah, it's good. So we take a couple minutes to go through this, and then we'll come back to some questions. Okay, so this is Project Artemis. Anybody know anything about Artemis? I didn't until I started looking into this. Go ahead.
So, I'm actually working on the gateway for partnering with Stennis.
Oh, excellent. Okay, great.
So-
Oh, there we go. Sweet.
So it's just the NASA plan to get humans to the moon by 2024.
Yeah, yeah. So what's the genesis of the name Artemis? Do you know that?
So Artemis is the, I believe, twin sister of Apollo.
Very good. Excellent. Yes, so, yes, Project Artemis is going to be a phased program that is going to involve NASA, commercial industry, many of the other nations to, as he said, put a man and the first woman on the south pole of the moon by 2024 as a very first step towards going to Mars. Okay? It's going to use commercial vehicles to do some things. We have things up here. You can see that the first one's going to go out here probably in a year or so. They're going to send one around the moon unmanned, and these are the first humans. We're going to do this thing called the Gateway, which is basically a space station around the moon. And the Gateway is a big portion of this because most of that's going to be put up by commercial industry. Okay, the European Space Agency is going to do some of the cargo resupply. The commercial industry is going to build that spacecraft and also the lunar lander. It's going to go from the space station down to the moon and back up. Okay, so you can see down here, they also have some commercial lunar payload services. This is the cargo lander, and the crews will come in with the Orion spacecraft that NASA is developing now. It's like a bigger Apollo spacecraft designed for deep space missions to keep people alive for weeks up to a month or so. Okay, and then the lunar South Pole. Why do we go to the South Pole? We think that there's water there in the form of ice. There are portions of the South Pole that are always shaded, that never see the sun, so if there's a place to find, and actually we found signatures of ice, water on the South Pole. Well, why do we want water? Well, what rocket fuel does most rockets use? Hydrogen and oxygen. Well, what's water? Hydrogen and oxygen. So if we can take advantage of what's called the in situ resource utilization, resources on the moon, we can make it a lot easier to go to Mars, because coming off the surface of the moon or coming out of orbit in the moon is so much easier than getting off the surface of the Earth, because here we have to go through not only 1G of pulling force, keeping you down, but also that heavy, dense atmosphere. So we have to tailor the thrust and the profile of our rockets to make sure that we don't exceed things called dynamic pressure and heating and things. So going to the moon and coming off the moon is much easier. You can think about all kinds of ways of doing things like electromagnetic rail guns to launch them. A lot of different things that can be done. Okay? So that's the plan. Oh, I have my clicker set up. There. Okay, so this is kind of a little setup of it, okay? We're going to do this. We're going to do the crew program, which is the SLS, that's called the Space Launch System. And that's NASA's new big rocket. Eventually it's going to be 9 million pounds of thrust. Both Apollo and the space shuttle were around 7.5 million. This is going to be a lot bigger to get things to the moon. So we have the first test uncrewed, then we have the first flight of the crew around the moon, and then Artemis 3 is the first crew to the surface. The commercial part of it down here, they're doing the power propulsion element, the pressurized module. You can see these commercially provided elements. Transfer landers from the Gateway to low lunar orbit, descent from the transfer vehicle to the lunar surface. And you can see the 3 commercial rocket launches. So How do we do that? Well, SpaceX has already launched 2 of their Falcon 9 Heavy rockets, which don't quite have the capability of the Space Launch System, but they're not that far off. And they've already launched 2 of them. So we already have existing commercial capability to get us there. So there's a lot of contracts that, that have been let to commercial industry to get us to where we need to be. This is a little bit of the gateway, so you can see the different parts of it. There's kind of a HAB module, pressurized HAB module here with docking ports for things. So we have an Orion module that will come in, and then the European space agencies building the service module. We're having a lunar landing system, which is ascent, descent, transfer. A lot of different things that are going to be needed for us to get to the moon and then start thinking about going to Mars. So I find this really interesting. Here is the moon. You can say it's basically black and white. And then there's our Earth in the background. So building on what I said earlier about the colors of the Earth and just the fact that it is just really amazing to see the Earth from space. There's a book out called The Overview Effect. It's been around for a lot of years, written by Frank White, but he interviewed a lot of us that went into low Earth orbit. He interviewed a lot of the lunar astronauts, and talks about kind of the perceptions of humanity when we go from the surface of the Earth maybe to an airliner where you look down and you look at Washington, D.C., and you can see the Capitol Mall, but you can't see the people, but you know that things are going on down there that affect you. The laws are being made, things are happening. Then you go into low Earth orbit, and then you have that sensation and that perception that I had of 90 minutes to see the whole Earth. It's really, it just takes your breath away when you think about that. And then he talks about the lunar astronauts when they go out there and they see this, and they put their thumb out and they can block out all of what we know as humanity with a thumb. It's pretty awe-inspiring. It's just really, it's humbling. So that's pretty cool. So that was my presentation. I'm happy to take some more questions. Yes?
If we have students who have ambitions like you had many years ago, what trajectory should they pursue at this point?
That's a good question. So, the best answer I can give is STEM. But we also need some humanity, and don't give up on the liberal arts. I know Tom is very big about that, and I couldn't agree more. We need humanity along with our science, technology, and STEAM. Okay, so science, technology, engineering, arts, and math. So any of those fields. I think that the thing that I can say about becoming an astronaut is you really need to do something you love. And if you don't do something you love, number one, you're probably not going to do the best at it that you could. And number two is if you're doing something that's kind of artificial, that you're trying to kind of fit into the mold, I guess like I started to do, but then got redirected by our Savior, that you may not be happy, because the odds of going into space are pretty slim, when you think about it. Doesn't mean it can't happen or won't happen, but you need to be prepared and do the things that you really love, and along that way, hopefully get into it. So some other things that are important are doing something that you kind of need to take some physical responsibility for your own safety, whether it's rock climbing or scuba diving or flying or gliders or a variety of different things where you're in potentially hazardous environments, and you have to demonstrate that you don't clutch under pressure. And I remember when I was being interviewed by the scientists for the payload specialist job, the first question they asked me was, well, can you tell us a time when you were in a physically challenging situation and you had to do some things to keep yourself safe? And my answer was 138 combat missions. So I mean, fortunate or unfortunate, but the way that my life has played out has been extremely blessed. I mean, I just thank God every day for all the opportunities I've had, and just the great people that I've met all along the way, and the ability to try to help influence some things. One of the things that I didn't talk about earlier, but right now I'm currently the chairman of a standing review board for NASA. That's we provide oversight for the whole commercial crew program, which is Boeing and SpaceX. So, after 20 years of being out of the space program, I was asked to come back and be the chairperson. And I've been excited about that for the last 5 years, to follow how Boeing and SpaceX are doing and working with the NASA management people and trying to give some oversight. When our board was first constituted, I did a little math, and we had over 300 years of combined spaceflight experience on this board of people, some retired NASA people, some outside NASA, some current NASA people. So we've been doing that and watching how it goes. So this will be an exciting year to see both Boeing and SpaceX start launching their crews to the space station and regaining an American ability and presence and way to put Americans on American spaceships and take them to the station. So it's really good. Yes, sir.
What year did we project that we'll be on the moon? A human being
On the moon, 2024.
2024?
Yes, sir, 4 years. Yeah, so it's quick. I just saw the submits, the budget submits. Some people probably get upset about it. NASA's budget increase went up 25%. And we need to do that if we're going to do this. This has to get going and happen now. You can't be just we'll increase it 4 or 5%. You need that big jump to get it done.
Is the moon just a stepping stone, or is there something valuable in it for itself?
Yes, both. It is a stepping stone, but there is intrinsic value in going to the moon so that we can learn to live and work in space outside of the Earth's Van Allen radiation belts that give us a lot of protection against radiation. Also, there's a lot of science, radio astronomy science, that can be done on the backside of the moon, because as we know, the Earth is gravity locked, or the moon, so the dark side always stays facing away from the Earth. So as we get more and more sensitive about doing radio astronomy and things, and we're trying to avoid the pollution from all the stuff that we radiate here on Earth, there's a lot of science that can be done there. And then finally, continued geological sciences to really understand the genesis of the moon and how different planetary bodies get formed. So I think there's a lot. I think
One
there's
of
a
our
question about that.
youngest spring harbor university students here. Really would love to hear your question.
Okay, he's being a little shy. He's curious how long you were in outer space, and we're also curious about sleep. Were you tied down to be able to sleep?
Good question. Okay, so my missions were 10 days and 9 days. And on the movie, you can see we had those bunks, okay? And we do that on the science missions where we're going to work 24 hours a day around the clock, okay? For other missions that they just do one shift of operations, like the space station, they don't have bunks like that. They just have a sleeping bag that's basically Velcroed to the wall, and then you turn the lights out. But since people were working 24/7, we had the bunks. The first couple of days, I was space motion sick. I was studying that, so that was pretty interesting. It was strange because, as a fighter pilot, I used to pulling G's and going upside down, and flipping around and doing all kinds of things. And I knew I wasn't going to get sick, but I did. But it went away after about 3 days, and it wasn't totally debilitating. You just didn't really feel great. And then, you'd use the bag, and then you'd feel better. And then a couple hours later, you'd start to feel bad again, and it kind of repeated itself. But we had some medicines that helped it out. So in the bunks, we did have these sleeping bags. And for the first couple of days, we would have like Velcro straps, so we could strap our legs and our chest down. And we even had a strap for our head, to strap our head to the pillow. And I thought that was really strange when I was going through this before I got into space. Why would you strap your head down? Well, the neutral body position in space when there's no gravity is you're kind of like this, okay? Your head's tilt forward, your arms are kind of up to your chest, and your legs are partly bent because as we stand up here and fight against gravity, all those muscles that are helping us stand up now are tending to make us kind of cramped up and with our head forward. So trying to sleep looking at your toes is not so natural. So we would actually use that strap to put your head back at night. After about 3 days, you just kind of get in the bag and zip it up. You didn't worry about strapping in because it's a little bit disconcerting in the middle of the night to kind of float around and bump into things. So it's just a matter of keeping you from being a floating object, hitting something.
We've got about time for one more question.
Okay.
Having gone into like a very heavily in science-based field, what are some adversities you faced, like involving your faith?
I'm sorry, what?
Some adversities you faced involving your faith.
I'm still not getting, I'm so sorry.
Challenges to your faith.
Challenges.
Being in
Oh,
science.
Thank you, yes. Yeah, so that's a good question. And there are a lot of people out there that are in the sciences, the hard science fields, that are not believers. But there are a lot of people that are. And there's a bunch of them here. There's a bunch of them everywhere. Years ago, there was a really good article in the MIT alumni magazine called Technology Review. And they had kind of point counterpoint. And they went through it, and I mean, some people are just not believers. Sometimes, if you're not careful, you can kind of get scorned a little bit. I mean, I think that, some people may look down at you, but I mean, personally, I believe, and there are an awful lot of people out there that do. So I think it's important that, your faith be grounded within you, that you don't let other people try to knock it out of you. So, yeah.
Would you please join with me in thanking Dr. Lippert? Sharing your story, your adventure, a lifetime still going strong of loving and learning and growing, and the experiences you've had have inspired us. So thank you very, very much.
I appreciate it. Thank you for the opportunity. You guys are a great audience.